Well, hi. Welcome to the lab. I thought we'd take a little bit of time today to take a look at some of the lab equipment that we use, some glassware and some instruments, so that when you take your first lab, you'll be able to understand what the equipment is called. And so I'm going to show you a few of these things and tell you how they're used so that you become familiar with them. I will tell you some of the glassware is a little confusing at first until you're used to the terminology. So hopefully we'll get you used to the terminology pretty quick. We're going to start with some basic glassware. Now there are three general types of glassware that you're going to be coming in contact with: beakers, flasks, and cylinders. It's pretty simple actually. The way you tell the difference between them will also help you understand how they're used. So we'll start with beakers. A beaker is anything with straight parallel sides. It looks kind of like a drinking cup, although you never want to drink anything out of here. But it has straight parallel sides. Sometimes a beaker has numbers on the side of it. But we don't really use this scale. We don't use these numbers to do really anything important. It's just to give you an idea of about how much is in here. They're not very accurate. You don't really measure with beakers. Beakers aren't used to make measurements. Beakers are used just to hold stuff. So you might put a liquid in here. If you wanted to boil some water, for example, quite a bit of water, you would put it in here. Beakers come in various sizes. This is probably one of the most common sizes. This is a 250 milliliter beaker, and again you'll see it's got numbers on the side, but we don't use those numbers for anything. And then they go very large, and they even get down to very, very small. This is a tiny little 10 milliliter beaker. And isn't it cute? It's cute. So a beaker has straight parallel sides. It may or may not have numbering on it. It's just used to hold stuff. A flask, on the other hand, the sides are not parallel. This side almost looks like a cone, and as a matter of fact, one of the names of it is a conical flask. But its more common name is named after the scientist that created it. It's called an Erlenmeyer flask. An Erlenmeyer flask has sides that are not parallel. They slope in. In other words, the mouth of the flask is much narrower than the base of the flask. In the case of a beaker, the mouth and base are essentially the same diameter, more or less, but flask is much narrower at the top, and this prevents splashing. So we often do chemical reactions in flasks, because if there's any kind of splashing, it'll usually be contained by the sides. This is probably the most common size. This is a 250 milliliter Erlenmeyer flask. You'll be using these every now and then. And again, they get very large or they get very small. This is a 25 milliliter Erlenmeyer flask, but you see it's the same shape, the same general size. Some of these may have numbers on them, but we don't really measure anything other than approximate amounts in an Erlenmeyer flask. If you want to measure volume, you need to use something called a graduated cylinder. Many of you have seen a graduated cylinder before. It's called a graduated cylinder because it has not only numbers, but many numbers and lines. I don't know if you can see those right along there. Numbers and lines on the side. This is what we use to measure volume of liquids specifically. It's fairly accurate. In other words, we can get a pretty good idea of how much volume we have in here if we read it correctly. There are different sizes. This is a 50 milliliter graduated cylinder. We have 25 milliliters, a little bit smaller, and we have 10 milliliters. They're very skinny. They don't hold quite as much. And the lines are a lot smaller on a 10 milliliter flask, if you can see how small those lines are on a 10 milliliter graduated cylinder. They're very small, and that means that we're actually able to get a very accurate volume, small volume, but very accurate with something like this. So we have beakers, flasks, and graduated cylinders. Graduated cylinders are really the only ones that we're going to use to measure volume. Beakers and flasks hold stuff, but we don't generally measure with them, even if they have lines on them. Some other glassware that you're going to become familiar with. You've probably seen something like this in most movies about labs, or you may have actually used these before. These are, of course, the ubiquitous test tube and the rack, the test tube rack that we keep them in. We need to keep them in a rack because if you look very carefully, their bottoms are rounded, which means they won't stand up. If I put it down on the bench, it'll fall right over. So we often don't want them to fall over because whatever's in might spill. So we put them in a rack to keep them upright. The test tubes are where we do small reactions. We do chemical reactions in test tubes all the time. Tests. Test is just another word for reaction often in chemistry. And if we want to hold a test tube, we're going to use a very specific piece of equipment called test tube holder. This is a test tube holder. You squeeze it together like this, the jaw is open, you can put your test tube inside like that, and now we can hold the test tube securely, but without having to actually touch the glass in case there's something very hot in here or if we want to put it into a flame and heat it. Test tube holder, test tube holder, test tube rack, test tube. Something that people get confused with the test tube holder and the test tube rack are these things. Now, these are called crucible tongues, and they have a very unusual end to them. See, they're kind of bent like that, and they have this weird sort of bent piece in the middle. Crucible tongues are not going to be used to pick up test tubes. They are used to pick up things that are very hot. You can hold something directly in a Bunsen burner flame with crucible tongues, or you can use it to pick up something, a hot piece of glassware, for example. If this beaker were a little too hot to touch, it's small enough I can grip it by the sides. But a crucible tongue was originally invented to hold, well, its namesake, a crucible. And a crucible is a small porcelain cup with a little hat. And inside this cup we can do some heating. We can heat things very strongly because porcelain conducts heat pretty well. And originally, this little weird bent piece in the middle of the crucible tongues was designed to allow the crucible to sit right in there. Unfortunately, if you don't have a steady grip or you relax your hand just a little bit, it'll slip right through and you'll break your crucible. So when we use crucibles, we don't carry the hat around with it, the lid. We just grip it by the sides, and that thing's not going anywhere. It's very, very secure that way. So we can carry it around the lab, we can put it up. We don't want to be touching it with our hands because it's usually going to be very hot. So we can carry it around with the crucible tongues. Pretty easy. So these crucible tongues, these, with the rubber tips, are called beaker tongues. And these are used to pick up hot beakers. Usually it's a lot easier than this, especially if a beaker is a little bit larger and full of boiling water. It's going to be very heavy and it's going to be hard to lift with crucible tongues. So we use the beaker tongues. They're padded, they've got a little non-stick or non-slip rubber sleeve on each of the arms, and we can carry around our beaker like that. So, we can heat liquids in beakers, we can heat solids in crucibles, we can do chemical reactions in test tubes or in Erlenmeyer flasks. What if we want to heat something? We keep talking about heating things. How do we heat things? Well, we're going to use something called a Bunsen burner. Here's a Bunsen burner. A very famous structure here in chemistry. We use these Bunsen burners to heat things all the time. In a later video, I'll show you how to light it properly. There's a right way to light this thing and a way that's not quite as efficient and more difficult. So I'll show you the easy and correct way of lighting a Bunsen burner later on. But we heat things with a Bunsen burner. This end of the hose gets hooked up to the gas, and we light the tip right here. I turn on the gas and light it, and we get a nice flame that can get fairly hot, about 700 degrees or so. Well, we can hold something directly over the flame using one of our tongs, but sometimes we just want to let it sit, especially if we're going to do, we'll let water boil. And so if we want to do that, we're going to set up a little structure called a ring stand with a ring and some other items that we might put on. So here is a ring stand, and it has this little platform base. We can often put our Bunsen burner directly on there, and then we can set something, clamp something to the stand itself. In this case, I have an iron ring. It clamps right on here. I can put the Bunsen burner right underneath it. And then if I want a platform or something, I can use, for example, this. This is called a wire gauze. It's made out of wire. It has this asbestos circle in the center that allows us to heat evenly. And I can put the wire gauze on top of the iron ring, and I get a very nice little cooktop. and then I can put my beaker on top of that and I can heat it nicely. So that's one way that I can heat things. If I want to heat a crucible up on my little oven top, I can do this, but there's probably a little bit easier way and better way to heat a crucible. We can use something called a clay triangle. This is a clay triangle, and that actually holds the crucible rather nicely right in place if we wanted to heat the crucible. When it's time to light the Bunsen burner, I use a sparker. This is a sparker. It creates a little spark, and I can light the Bunsen burner. Again, you'll see this later on when we go ahead and show you how to light the Bunsen burner. Just a couple more to do, a couple of other pieces of equipment that you're going to be using that you want to become familiar with. Anytime you need to take some powders or crystals out of a beaker, for example, or out of a bottle, you're going to use this thing. This is called a scoopula. It's like half scoop, half spatula. And so you can reach in and you can grab some, and it sort of sits right in there. It's like a little spoon. It sits in there, and you can transfer it from one place to another. So this scoopula is used to get solid powders or crystals out of bottles or beakers and put them someplace where you want to use them. This looks like a giant contact lens. It is in fact called a watch glass, and we can use this. We can put something on there to observe it. We don't ever heat a watch glass. Be very careful. Sometimes you might want to heat this. Don't heat this. This Pyrex that it's made out of is pretty fragile, and it'll crack if you try to heat it. If you do want to heat something in an open container that's not like a crucible, you can use the crucible's big brother. This is an evaporating dish, and you can put something in here and you can heat it very strongly. It's also made out of very strong porcelain. It will heat very well. You can put it in here and it will, well, it'll evaporate whatever liquid might be in there. So evaporating dishes are better to evaporate liquids over heat. Most of you probably know what this is. This is called a filter funnel. This is used when we need to filter a solid out of a liquid. We put a piece of filter paper in here. We pour our mixture through. The solid gets stuck in the filter paper, and the liquid goes right on through. Same general idea as a basic coffee maker. That's kind of how coffee makers work. The coffee filter is the filter paper. The structure that you put that filter in is like the funnel. And the mixture is the coffee grounds and the water going through it, and what comes through is what is dissolved, what's mostly liquid. So we use the coffee filter funnel. Just a couple more. This is a glass stirring rod. It is used, you guessed it, to stir. It's glass, it's Pyrex actually, so it doesn't react. You generally don't want to stir with metal, especially if you have acids or things that react with metal. Use Pyrex because it's not going to react. This looks like an eyedropper. It is actually called a pipette, and a pipette is used, well, that's what an eyedropper is. It's a pipette. So if you want to suck up a little liquid in one place and put it someplace else, you use a pipette. These things are disposable. We throw them out all the time. If you use them, generally they get a little dirty. You can't clean them real well because the opening at the tip there is very, very small. So we just throw them out. And finally, a thermometer. You're going to need to take some temperatures occasionally. This is a thermometer. Now this one is a mercury thermometer. We probably will not be using mercury thermometers, even though it is coated with something so that it won't break. We generally don't like to use mercury, so the ones that you use will probably be alcohol. It means they'll have a blue or red liquid in there, still used to take temperature. So that's a lot of equipment. If you've just watched this video through without pausing, you're going to miss a lot. You should probably go back and use the handout that has all the pictures and write in their names and write down maybe their structures or their functions so that you know what they do. You're going to start to need to know what these things are, because when we do labs, in the lab description it'll say, take a 50 milliliter graduated cylinder. Well, you need to know what to look for if you're doing a 50 milliliter graduated cylinder. So learn your lab equipment, learn their names, learn their basic functions, and don't forget to do the whisk at the end of the video, and we'll see you later.